2, 1. All right, so welcome back if you're still studying poker. So here's a question which I got from JLot 159. I wasn't able to answer it at the time, I was time constrained, so I couldn't answer this one. But I thought that it was a great question and I wanted to follow up on it because it's quite challenging actually to be able to count this one up. So the question was this one. So if you're drawing your regular standard 5 cards, okay, from a 52 deck card, like you would in poker, so you can have a flush, a royal flush, you can have 3 of a kind, etc., etc. Well, so this one is nothing really like that, but what it is it's stating that we have to have at least 3 cards out of those 5 that have a different suit. Okay, so that's 1. Now, within those 3 different suits, they're only allowed to come out of an ace, a 2, a 3, a 4, or a 5. So as you can see here, okay, so you can have, these are the only choices that you are allowed to have within, okay, those 3 suits. However, this is at least 3 suits, all right? So it could be 4 suits that you have. And this is where the problem lies. And this is actually a relatively difficult question. So just to get you started, so let's imagine, okay, this could be something like this. So ace of hearts, okay, so you picked one out of here, okay, 1 suit is covered, all right? Okay, let's say the other one, let's say it's 3 of diamonds, okay, another suit is covered, all right? And let's say we have another ace, okay, of spades, okay, another suit is covered. And now for the remaining 2, you can have whatever it is that you like. So it could come from these cards, or it could come from the remaining 32 cards that you still have. All right, so it could be, for example, 10 of spades, all right? And it could be maybe, let's say, one of these again, maybe another hearts, like a 2 of hearts. And that's where the problem comes, where you are drawing both from this set and the other set, and you're allowed to have anything that you like, all right? So let's dive into this, okay? And then how are we going to break it down? So first of all, let's concentrate on the 3 suits. All right, so we have only 3 suits that we are allowed to have. Now, you'll be surprised, but a lot of things can happen in here when you're choosing 3 suits. So whenever you choose 3 suits, okay, so I'm going to put in, so here are my cards, 1, 2, 3, 4, 5. Okay, so pardon the sloppiness in here. So within this, if you want 3 suits, okay, and only 3 suits, okay, so this is kind of the first case that you would have. So you take 4, choose 3. Now, why? Because we want 3 suits out of the 4 suits that are possible, all right? So that's what I'm going to have. And now I want to be able to put these cards, okay, in here and ensure that they're of different suits. Now, if I pick different suits, then each suit, okay, I can pick 5, choose 1, 5, choose 1, 5, choose 1. Why? Because I have 1, 2, 3, 4, 5 cards to choose from, but I'm only going to choose one of them for the suit that I want, all right? Now, for the remainder, okay, so for these remainder that I have in here, I'm going to now restrict it. So as I said, there are really 32 other cards that you have, right? The 6s, 7s, 8s, etc. Okay, and I'm going to stick these, okay, into here. So I'm going to say 32, choose 2 out of those cards, okay, to fill up these 2 spots. And this is going to be kind of my first item. So really what I have is I have 4, choose 3, multiplied by 5, choose 1, cubed, multiplied by 32, choose 2. All right, so that's my first thing. Now, what a lot of people will want to be able to do is they will want to be able to do this. Okay, instead of 32, because they say I can pick any 2 cards that I like in here, right? So I can pick any 2 cards. Notice you can also pick from here. You might be tempted to say 49, choose 2, because you've picked 3 cards and you have remaining 49 cards. So logically, you should trace back why this is incorrect. This is incorrect because you're going to be double dipping. You're going to have combinations from both of them. And I'll leave it up to you, okay, to convince yourself of that. Okay, if you want, you can put down a comment, and if I see a comment, then I'll give you, okay, what can happen. Okay, but this cannot happen, okay, in here. So we can't just kind of blindly take this out. And one of the key rules is that you may want to think about is when you are doing combinations, okay, and you're picking cards, and you have two separated sets. So you have a set over here and then another set over here. Don't mix them together, because when you mix things together between two sets, you have a likelihood of double counting. And that's what happens when you do 49 choose 2, because you mixed two sets back together. You've already picked them out of one set, and they might appear again in the other set as well. Okay, and then you might double count. Okay, so that's something that you may not want to do. So meaning separate them. All right, so that's my first one. Now, still on the 3 suits, right? So as you continue on, so what else can happen in here when we have 3 suits? So as you're continuing on, so I'm going to say 1, 2, 3, 4, 5. So how else can I have 3 suits? Well, I can have 3 suits, but I can have, for example, out of those 3 suits, so out of this particular set, instead of picking only 3 cards, what if I pick 4 cards out of there but still maintain 3 suits? So how can this happen, right? So that means, I'm going to have basically, so I'm going to dive and break this up, that I'm choosing out of the 20 cards, so from the ace and the 5, 4 cards. And then for the remainder, okay, so over here I'm going to have 32 choose only 1 card out of the other set. All right. So number 1, okay, so if you think about this, okay, so how can this happen? Well, so this can happen in the following way. So you can still say 4 choose 3, right? Because you want 3 suits to be delivered to you. Now, if you're going to do that, that means one of the suits is going to have 2 cards. So, you're going to have one suit with 2 cards and the other suits with just 1 card, one single card. So you're going to say 4 choose 3, but this time around, okay, it's going to be 5 choose 2, 5 choose 1, and then 5 choose 1 again. And this is, again, another tricky component, because what you have to now be careful with is the fact that if you do choose, okay, so let's say that this one was hearts, diamonds, spades. So in this time, hearts had 2 chosen cards, right, when you chose 3 suits. But, of course, you can say, well, diamonds could have been 2 cards, and then the hearts and the spades could have been a single card. So how many of these combinations will you have? You actually will only have 3, meaning that hearts will have 2, or diamonds will have 2, or spades will have 2, right? So in here, you still have to take this and multiply the entire thing by 3 of those combinations. So be careful, and that's, again, something that many might miss. So this becomes now super complicated because it says 4 choose 3 multiplied by, okay, all of this junk, 5 choose 2 multiplied by 5 choose 1 squared, all right, and then the last 32 choose 1. So yes, very tricky, right, as you're kind of moving along. Now, can you have 3 suits among 4 cards in any different way? Because that's something you also have to think about. So can it happen that you have 3 cards, right, from one suit? No, because then that means that would leave you only 1 other card out of the 4, so that would be 2 suits, okay, within here. So there really isn't any other way that you can, make this particular item happen in here, okay? Not at least that kind of come to mind. So that means you have 2 of these, okay, and then there's really nothing else, because any other combination, okay, that you will have will be this one. Okay, so that's 3 suits, okay, with 4 cards. Well, you can still continue the 3 suits, except now instead of picking only 4 cards from the 20, you're going to pick 5 cards from the 20. 1, 2, 3, 4, 5. So meaning you're picking from these all the cards, but you want to maintain still 3 suits. So, how can this happen? Well, that means you're not choosing any cards from that other 32. So this can happen in numerous ways. So for example, you can choose 2, 2 and 1, right? So that's one combination, okay? And then what else can happen? I guess you can have 3, okay? A 1 and a 1. And actually that's it. You can't really have anything else. Okay, meaning you can't have 3 suits, okay, so any differently. So here you can have 1 suit with 2 cards, another suit with 2 cards, and the third suit just with 1 card. Or you can have one suit with 3 cards, but then that means the other 2 are just single suits, right? That's all that you would have in here, and you wouldn't have anything else, okay, beyond this. So, let's kind of dive in and see how, how would we find the combinations for those. So within 3 suits, again, so you can still choose 4, choose 3, because you're picking 3 suits in here. But the first one, so 5, choose 2. The second one, 5, choose 2. Okay, and the third one, 5, choose 1. Right, so that actually completes those. And again, now notice that you're going to have to multiply this by 3. Because once again, so if you take a look at this, let's say this is hearts, diamonds, and let's say spades again. Right, so spades has only a single card. Now you can swap the, let's say, hearts and the spades. So now heart only will have 1. And then of course diamond can only have 1. So this whole thing you're going to have to multiply by 3. Okay, within here. And that would give you the whole thing. So this is going to be 4, choose 3 multiplied by 3 times 5, choose 2. I guess this is squared. And then multiplied by 5, choose 1. So that's what you would have over here. Okay, so that's for this one, where it's 2, 2, and a 1, okay, amongst them. Now, the last one, so the 3, 1, 1, so I think you hopefully get the gist now. So 4, choose 3, obviously 3 suits. So now 5, choose 3, 5, choose 1, 5, choose 1. Now, if you're still watching this video, you can pause it and then see, can you actually figure this out, okay, on your own. And now again, you're going to have to multiply this whole thing by 3 because the 3 suits can swap. Because one of the suits has 3 cards, okay, so that means you can swap it with another one, then it will have 3 cards, and then another one. All right, so I hope that convinces you there. So you have 4, choose 3, multiplied by, this is going to be 3 times, and again, so 5, choose 3, I guess, and times 5, choose 1 squared. All right, so that's what we have. Now, this one, because we've have chosen 5 cards in here, right, from one of these. So if I kind of zoom out in here, let me try. Okay, so this is when we chose 5 cards, okay, from the set of 20, right? That's what we had there. This one over here, okay, so this is, okay, the above one. Okay, so this one is when we chose 4 cards, right, from the set of 20, but still always with 3 suits. So please remember that, 3 suits, right, 3 suits, okay, 3 suits, and yeah, so that's what we had within here. So those were all the 3 suited ones, where you started off with just 3 cards from the set of 20, then you started with 4 cards from the set of 20, and then 5 cards from the set of 20. And as you can see here, this becomes complicated, right, as you're going along. So it's not a very easy problem, but it's an amazing problem because it really will test you. Do you understand this stuff or not in terms of counting? And there isn't really an easier way to do it. I mean, I thought about this quite a bit, actually, and you do have to take the separate cases. Now, I've done it with complements as well, right? So complements meaning, take all the combinations and then just subtract the ones that don't have, okay, these, right, which is the complement one. But it's actually not any easier. I did it with both. But so within here, so the last one, now what about 4 suits, right? Because you're allowed, it says you can have at least 3 suits. But what about 4 suits? Okay, you can certainly have, 4 suits within here, meaning 4 suits from those 20 cards. So if you were going with this 1, 2, 3, 4, etc. So if you're going to have 4 suits, well, what can happen? Okay, so the last one. Okay, so this is 32. Choose 1. Now, when I say 4 suits, I mean 4 suits from the ace to the 5. So that means you're going to pick all 4 suits. So 4, choose 4, which is really just 1, and they're all of them. Okay, well, it's going to be just a single card. So it's 5, choose 1. 5, choose 1, 5, choose 1, okay, and then 5, choose 1, right? So that's all of these, okay, within here, and then times 32, choose 1. So this becomes 4, choose 4, multiplied by 5, choose 1 to the 4, and then multiplied by 32, choose 1. Okay, that's 4 suits right there. And that's 4 suits with 4 cards, right? There's no other way, you know, you can only have a single card in there. But you can also have, I guess, 4 suits in all the 5 cards. 1, 2, 3, 4, and 5. So out of the ace to the 5, you can choose all of them. And then, so how can this happen? Well, you can't have 3 cards. That would have been only 3 suits. So really, I mean, there's only this one, right? So it's this one, okay? And then the rest are singles, okay, that you have in there. You won't be able to do anything else. So that, again, means 4 choose 4. And now this first one's 5 choose 1. And then the remainder ones, so 5 choose 1. I'll just put already cubed, okay? So it's 1, 2, 3. So that's what you have there. And again, okay, you have to be careful in here because one of the suits that you chose has 2 cards and then the other ones don't. So that means you have to take all the combinations, okay, that you would have in there. So you have to swap them. You know, if hearts had 2 cards, well, on the next one you can have diamonds has 2 cards, spades has 2 cards, and so on. So this time around it's not times 3 but times 4, right? Because you have 4 of the suits in here, okay, that you're choosing. Okay, so that is that would be kind of the only one. There's no other way to choose 4 suits amongst 5 cards. You know, you can't say 2, 2, and 1 because that's 3 suits, right? You can't choose 3, 1, and 1. That's again 3 suits. Okay, so it's only, you know, basically just means you can only choose 1, 1, and 1, and the last one can be 2, and that's it. Okay, and if you're only choosing a single card, then it would have been in the previous case. So those are all of the possibilities, which is pretty, you know, crazy to be able to do that, okay, as you're going through here. So 5 choose 1 cubed, okay, so this would have been it. Now you would have to add all of these up, okay? So you're gonna have to add all of these combinations up. So as you're adding all of these up, of course, you know, once you add it up, then you're gonna divide by 50, 52 choose, so 52 choose 5, and then you're gonna get your probability, and you can multiply by 100 if you want it as a percent. So yeah, it's gonna be a lot of work. Okay, so here you go. So those ones are actually all of the different items and combinations that we had in here. So I put it into my calculator, which allows me to do it. So I just define them, you know, C1, C2, 3, etc. And you'll see them, okay, that they're all there. So I had 1, 2, 3, 4, 5, you know, 6 different items, added all up, divided by the 52 choose 5, and you'll see there. So it's about 14.5, you know, 4, etc. %. That's the probability, right? Hard question, very, very hard question. So 1, 2, 3, 4, 5, 6 different ones. If I go back in here, hopefully I didn't butcher it. Okay, so within here, so, you know, what are they? Okay, so here's 1, okay, so that's one of them. Here's the other, okay, that's another one, that's 2, that's 3, this is 4, okay, this is 5, okay, and this is 6, okay, so that's all of them right there for you. Okay, so if you wanted a challenge in poker and counting, well, you know, there you have it. So thank you to the question which was sent in. I mean, you can make a lot of these different questions. I don't know where this question came from this particular, I don't know if it's even a subscriber, okay, to the channel, but so someone that has posted this up. Okay, so I hope that it actually helps you. I think if anyone is watching poker and trying to learn, this is a really good exercise to be able to see this, and it just shows you if you intuitively understand. Counting is tough, okay? It's not that easy. All right, thanks for watching. See you in future videos. Okay, cheers everybody.